actually, before I get that. Show you. There you go. If you go to my website, there's your final exam review. So first question, the graph that we did, we'll talk about this on Tuesday. Some differentiation questions, a limit, tangent line. There's your chapter 4 question, find all the different pieces for that function. There's your wonderful word problems. And there's your integration problems. So there's 14 questions on the final. But some of them have multiple parts, so why I said it actually works out to be right around 20. So today, I said we're going to look at the integration parts because we were finishing that up. So it's a good review. Make sure you actually understand things. So let's start with this one. So one of the things, I went back and looked at my notes from last year when I did it, and one of the things that I noticed that actually helped some people when we're looking at the U substitution was this extra step. So what's the piece in this problem that would be annoying? What's the part that you think I'm going to substitute for? Yeah, the piece inside. So that I'm going to make u x to the 4th plus 2. So with the u substitution, we now have to do the derivative of that. So what's the derivative of x to the 4th plus 2? 4 x to the 3rd dx. Now, this is the change from what I showed you the other day. It doesn't actually change the answer. The answer works, but it might help you understand it a little bit better. We're going to take whatever's here and move it over here. So I have du over 4x to the 3rd equals dx. So because now, when I rewrite this, I have x to the 3rd, cosine of u, and then I have du over 4x to the 3rd. Now we can see, okay, I'm going to cross those two out. That's what happens to those. They disappear. Because one's on the top and one's on the bottom. And what's left is that 4, which is the constant that's left, and we can pull that part out. Does that make a little more sense on where things were going and whatnot? All right. So what's the integral of cosine? Sine. So I have 1/4 sine of u, which is 1/4 sine of x to the 4th plus 2. That's the final. So if that helps, it's fine. It'll basically take whatever's over there, divide by it. When you put it into your problem, then you can cancel out the pieces that are there. All the x's should be gone. If all the x's are not gone, you've done something wrong or it does not work in this method, which is possible. All right, there are certain things that will not work with U substitution where they might look like they do, but they don't. So if you cannot cancel out all the x's in this step here, we have to try something else. Maybe look and see where you can substitute something a little bit differently. Any constants that are left or coefficients that are left, you pull out in front. So since it was on the denominator, that's why it becomes 1/4. It's not 4 that I'm pulling out. That makes sense? All right. Try this one. Well, I can't break this up. What I'm doing is do division. Just the box. Yeah. That's with the back. Otherwise, that's where you start. So if this problem was reversed like that, I could split this to the two pieces. And then we could do it. It's not though. And since it's in the denominator, I cannot split the denominator that way. Okay. So we need some. And actually, when you do figure out how to do division, you're not going to want to do the division rule for this problem. You're always going to want to look for your substitution first, because as much as you might think it's hard now, it's way easier than the other methods. So the denominator is what's causing me trouble. So let's make that u. So this one actually works out to be the same as the last one, 4x to the third. So we'll bring it over. So I have du over 4x to the third equals dx. So the integral x to the third over u, du over 4x to the third. So those will cancel out. I can pull my coefficient outside, and I have 1 over u du. So what's the integral of 1 over u? ln. So that's 1/4 ln of u, which is 1/4 ln of x to the fourth minus 5 plus c. I did forget the plus c in the last one. And you do need the absolute value in this situation, because x to the fourth minus 5 can be negative. So, and ln can't be negative. So you do need the absolute value in that situation. All right, try this one. always look, like, if there is something that's sort of crazy. This one's not really crazy. This goes back to one of the questions that was actually on the test. Don't always look for the hard way to do it. U substitution is great. It works well, just like L'Hopital's rule works really well, but you don't always need to use those rules. Okay. Part of the process of understanding like integration, differentiation, those things is understanding when and where you need to use the rules to do the problem. So in this problem here that we did before, the first thing I looked at is, can I do anything with that fraction? Okay, in this case, because this is on the denominator, I can't split it up, so there's nothing I can do. Okay, so let's now, since I can't break it down, I've got the division, I can't do division, so let's look at U substitution. In this one, there's nothing divided by, it's broken into two pieces. We know we can split up addition and subtraction. There's no real crazy square roots or e's or anything else in there really. It's just an exponent, a variable to an exponent. So it's as simple as it actually looks in this case. So what's the integral of x to the 1/3? Mm-hmm. And what's 11? The integral of 11x to the 4/5 or 4.5, not 4/5. 4.5. So it's 11 over 5.5 x to the 5.5. This one you actually can reduce it to 2. So plus c. That actually messed up quite a few people on the test. It wasn't just a 1 or 2 people. There was a limit problem on there that all you had to do was plug in pi by 4, and it would give you the answer. And about half the class decided to try to do the L'Hopital's rule for it and went down that rabbit hole. So don't always jump to the most complicated concepts. Okay, it's like I know we're looking at U substitution and pieces, but not everything always needs U substitution. Let's do. I'm looking for specific problem type stuff. So that's why it's taking me a second to pull up the problem. All right, try this one. you're stuck on. Because you have access. So go back and switch your view. I'm looking at it like this. Well, that works. Go through the process, see what happens. That's why I put this one up. Everything's fine. Keep going over this project. Yeah. This is a perfect example of getting ahead of yourself and thinking something is going to happen and then doing it and not following through the process. So U is the square root of X. Perfect. So du is 1 over 2 square root of X dx. Correct? Okay. So if we bring everything over, I have 2 square root of X du equals dx. So what most did, or what a lot of people did, not everybody, was you went this way. And you lost this. If you left that there and put that there, that and that cancel each other out. So the other way you could have done it is if you did actually change this to a U, you should have realized that that right there, that's also U. So they would have still canceled out. Because remember, you can't have any X's left in your problem. Right? They've all got to be U's in that situation. So we end up getting a 2 on the outside, and then the integral of e to the u du, which is 2e to the u, or 2e to the square root of x plus c. And let's see, which one do I want to do next? Let's do this one next. Just look at it as X squared. Those are done. Oh, you don't have to do that. You did the derivative. You did the integral. So these is fine. So that's why I was like, I thought I saw the I thought I might have been doing substitution there for a second. That's yeah. Biggest error in this one is subtracting instead of adding. It's a negative 3/4. So if you add one, it actually gets bigger, not smaller. So a lot of people do -7/4. So -3/4 plus 1 would be 1/4. So we have x to the 1/4 over 1/4. And then we're evaluating it from 1 to 16. So this is the x to the 1/4 is the fourth root of it. So it's 4 fourth root of x. So then we plug in 16. The fourth root of 16 is 2. The fourth root of 1 is 1. So the answer is 4. So these two numbers are just plugged in at the end. It's not anything crazy. And those you don't have to put the plus c, remember, because we have a definite interval. Are they getting a little easier? Process is starting to make a little more sense. All right. Then I'm going to choose not to totally screw you up yet. I have one that we're going to do tonight before we leave. It's just, I don't want to totally screw you up yet. Let's do this one. And I totally forgot to record, but it's fine. Oh, wait, no, I am recording. The integration one, then the control page. Is like side, but we are side. That's what it- there are- We kind of have to, because remember function inside another function. Do substitution, change all that. So have something inside of something else. The one, top of those. It's always top on this one. So the one like you're subtracting. I see that. That's people too. Anytime you have something inside of something else. There's one minus X inside of the opposite thing. Or you could FOIL it all out, but I don't think any of you really want to FOIL out. Yeah, that's what over. You're not putting the values, you're putting the values to your integer. Right. So, oh, it's, yeah, what does it have?
Yeah,
Over
which
10.
way, yeah, which way is when I do this.
Yeah.
Yeah, I'm like, see.
No, it would be like this, but you're forgetting over 10.
Okay.
I had to get.
I was just asking.
Yeah. It's just, you do the whole piece first, not the individual. You actually did miss something. Actually, I don't think that's it. I don't think you did. I don't think it's 9/10. We're gonna find out because I haven't done this one yet.
Yeah.
All right, let's see. So my u is going to be 1 minus x. So du is just negative dx. So I'm going to bring the negative sign over. So I get to pull the negative sign out front. And I have u to the 9th du. So that becomes u to the 10th over 10. Yeah, not the 9. And we're evaluating that from 0 to 1. So I have negative 1 to the 10th over 10 minus 0 to the 10th over 10 equals negative 1 tenth.
Neither.
Huh?
I see what you're going to say.
Yeah. That's what I'm saying. You need the 10 underneath. So it's the whole piece you put in there.
They were.
And this one it does. It did make a difference in this one. Yeah. Because of the way this problem worked out, it won't always work that way though. So that's why when we're looking at like this one here, same concept. Basically it's 4 to the 4th root of 16 minus the 4th root of 1 is the two pieces there. So like this one, if you tried to do your way, you would have done the 4th root of 16 minus 1, which wouldn't have made sense. So
That's why I said the ones are different.
yeah. All right. Oh, by the way, this one was an exam question or a review question. That's one of the ones that was on the exam review. This one is. And the next one maybe. This is the third one that's on the exam review. Okay. Anytime you don't need one. Go through there. You did the info already. Did you take the interval? What happens? Right. So that's called. Very good. Good. Totally good. That's what you do.
I went over it. I opened it, that's-
Yeah.
That's good.
That's why I like, that's why I tell people never do classes. Between classes to actually like digest
I
the
did
information.
So it's up for even that.
Way over top. Maybe that. Like I'm teaching stats this summer and like every day is basically a chapter.
I need my time.
Yeah, you need time to digest and understand the material. This is why at one point we were talking about, because of gas prices and stuff like that, going to a 4-day school week. And everybody's like, we want Friday off. I'm like, no, that's the stupidest day to have off, or Monday. You want Wednesday off. Like, why? Because for education purposes, it totally makes sense. You have 2 days of materials, you have a day to digest and literally like understand and decompress, and then you have 2 days of learning, and then you have 2 days off. It's like it breaks up that mass of information, which for kids and students is important. All right, what's my U? Yeah. So this one's like that other one where you had the U kind of like would have the same kind of things in it as the other one or the other piece. So if we took the derivative of this, we get negative e to the x dx. So we bring it all over. So we have the integral of e to the x over u squared du negative e to the x. The e to the x's will cancel out. So we have the integral of negative 1 over e u squared, which comes out to be negative 1 over u. So I have 1 over 7 minus e to the x plus c. This is one of those ones that's really easy to lose a sign. One of the reasons I always take whatever is left over and put it out in front. And then I put parentheses around what I'm doing the integral for, because it's really easy to go, oh, I already have the negative sign there, I'm good. You have 1 over negative u. Or sorry, 1 over negative u. So 1 over squared is u to the negative second. Add 1 to do the integral of that. You get u to the negative first negative 1, which is what gives you that. Because the negative 1 goes back down the bottom. All right, let's do this one. I'll give you a hint. That's you.
Inner part.
Not necessarily.
So,
Like, I got that part. I feel like got that part right. You were on the right path. You still have that. I don't have that expert. But you wait, you replace x squared plus one with u.
Yeah.
When you do the derivative of that, you get two x. So how did you get rid of the x to the third on the top?
So,
Right, so you're gonna add squared.
Yeah.
How do you get rid of the x squared?
who is X?
Okay. Yeah. That way doesn't work. You actually weren't horribly wrong, like you weren't on the total wrong path. You just missed one key ingredient. All right, so I'm gonna what you got. You can stop at that. Pretty much everything. This was my problem that I was like, let's see if I can confuse them. We run out of light up. Well, simplify it first. Let's get it as simplified as you can. You're not going to do the interval, but get it as simplified as you can. Oh. What did I say before? We can't have any experts, right? We can't have any X's. They'll have to be used. So this is what I said. You weren't so far off. What's x squared equal? If I solve that for x squared, what do I get? So I can change this to 1/2 u minus 1 over u to the 1/2 du. No more x's. So that's what I said. You weren't far off when you were like, oh, I have u up there and totally that actually was good. You just, this was the piece that you missed. And honestly, if anybody in here got that, I'd have been impressed. Because that's one of those, like, it's a little tricky, like, way to manipulate things that most people just would not have thought of at the beginning. Now you still have a problem with do that. What if we say, in one of the very first problems we did, right? I said when you have a single thing on the denominator, you can split it. So split that up, maybe 2 fractions instead of 1. And yes, there is a way, there is certain situations where you would actually use substitution twice. This is not one of those cases. But it's also. Yeah, so now stand that up. So I'm the first one read the one out. Do your next one. Oh. And then the next one, the second one. Okay. Put those together and make that. So you can just use next one. Power. Put that in. This is all those little algebra skills. On that. So this goes to u over u to the 1/2 minus 1 over u to the 1/2. So I have u to the 1/2 minus u to the negative 1/2. And bring it up so I have the negative, take care of the negative. Now I can just use my regular rules. So that becomes u to the 3/2 over 3/2 minus u to the 1/2 over 1/2. What was my u originally? X squared plus 1. Let's do Hi, Copilot. I don't want you. Let's do this one. Very cool, actually. No, it's gonna be done spot. Yeah. No, it's gonna be done well. You're not multiplying to get it out of it. It's literally just working back. The drop of the pot. I just put the link to it. Yeah. That's what we're doing. The one that- Yeah. The sun's almost there. So we plug in 1. We get negative cosine of 3 pi, which is -1, right? -1. So negative negative would be a positive, so that's 1. Minus, plug in the 0, that's -1. So you've got 2. You put your 3 pi in the wrong spot. So it's 2 over 3 pi. Which one? There? Oh, +1. It was minus a -1. Do I have a note? I do have a note. Can't do that. That's not multiplied. You could do what I did, but still left with a 2x. So what do we know about addition and subtraction with integrals? So we've done one. Like this one. How did you do this one? Did you do it all at once? Or did you do the integral of the first one, the integral of the second one? You did it in pieces, right? So addition and subtraction I can split up. So I could split this into two pieces. Okay. One of the things like you can't do with it with multiplication division, but you can with addition and subtraction. So this is easy, right? That's just going to end up being x squared. This, on the other hand, we run into that problem. When I make u the 16 minus x squared, du still has a 2x in there. And I have no way to get rid of the 2x. So this problem right here, you can't do. Actually, let me see. For shits and giggles, I don't think that problem can be done. Oh yeah, we have to do trig substitution. Chapter 7.3. You learn how to do that problem. But what's that make? Square root of 16 minus x squared equals what? What's this make? Which shape? Can I get rid of the square root? Yep. I move the x over. This is actually a circle. An ellipse has division. So this is a circle with a radius of 4. So what's the area under half a circle? Because if I graphed it, it was going to go from -4 to 4, which is what I was looking at, right? What's the area of a circle with a radius of 4? It's pi r squared, right? So that'd be 16 pi for the whole thing. For that part, would be 8 pi. Correct? What's integration give me? I was not expecting you to know this, so don't like. What's integration give me, though? You should area. So that right there is 8 pi. Again, I wasn't expecting you to get it. Don't worry. No. I did this problem specifically because I wanted to relate back to what integration was. I wanted to connect back to that integration is really the area. So in this situation, when you got this problem, this actually problem was in the book and it's solved by using area. This one we could easily do. 4 squared is going to be 16 plus negative 4 squared is going to be 16. So the answer to this problem is actually 32 minus 8 pi is the actual answer for it. So I wanted to connect back that the integration is really area. So sometimes when you look at a problem, if you can't solve it out algebraically or using the rules of calculus, sometimes you can use the actual definition of what it is to be able to find the problem. And that one was a circle, so it made life a lot easier. So yeah, the only difference between a circle and ellipse has the x squared divided by something, and that's what shifts and stretches. And typically it equals 1 at the end. Yeah. So it'll be like x squared over 3 plus x squared over 5, or y squared over 5 equals 1. And that gives you your axes, your major and minor axes in the ellipse. All right. Want one more? And then we'll go. We don't need to do another one. We're good. We will finish up the review of the derivative problems and stuff on Tuesday. So the review for the final is already up on my website, so you can start working through it. I would suggest going through and doing some of it before class on Tuesday, so this way you can at least have a general idea of what ones you're going to be struggling with. The other thing, Blackboard's completely updated with all your grades. I updated all the homework grades in there. Chapter 5 is due the day of the final, so don't forget to do Chapter 5 for the homework. I will put that grade in after the final for it. So, I'll put it all in. Yeah, I'm going to update all the grades after the final. So that's I updated them as of today. So, if you didn't get an email from me, you do have to take the final exam. So there was 3 lucky souls. The final exam will replace your lowest test grade. So if you have a low test grade and your final exam is higher, then it'll replace it to improve your grade. All right. I will see you on Tuesday. I don't need to see you again. So that's fine. I was going to say just do Chapter 5 homework. That'd be that. But other than that, you're good. Did you check your email? I don't need to see you again. So if you don't want to come next Tuesday, you're good. So, if you want to come next Tuesday, great. You're more than welcome to. I'm just saying you don't have to.
See you Tuesday and Thursday.
Yes. Nope, not Thursday.
Tuesday.